physicists Penzias and Wilson, they discovered CMB accidentally in the year 1965. They were working with an antenna at Bell Labs, and they discovered at that time a persistent noise which was consistent or uniform in all directions. Later they investigated, they analyzed that persistent noise, and ultimately they discovered CMB, means cosmic microwave background radiation. And this discovery led them to earn the Nobel Prize in Physics in 1978. What is CMB? It is nothing but the afterglow of the Big Bang. And it took 3,80,000 years after the Big Bang. 1 lakh is equal to 100,000. Okay. Everyone is not familiar with the term lakh, LSE lakh. Okay. 1 lakh is equal to 100,000. So I am talking about the time 3,80,000 years. Yes, this much time were required for the decoupling of photons. After this time, photon particles could emerge from that area, and that's why at present we can see that thing. That is, we can see the CMB radiation. So after that time period, 3,80,000 years, recombination started. Recombination of protons and electrons to form neutral hydrogen atoms. And before that, the universe was like a hot dense plasma consisting of protons, neutrons, electrons and photon particles, means light particles. But for the photon particles, it was not possible for the photon particles to emerge from that area, okay, because the photon particles were constantly interacting with the electrons, which is known as, you know, that Thomson effect or Thomson scattering. Okay, protons are charged particles, electrons are also charged particles, but in the Thomson scattering, the contribution of electrons are much more as compared to protons. Anyway, recombination, this process started after 3,80,000 years, when there was sufficient expansion of the universe and the temperature dropped to 3000 Kelvin, only 3000 Kelvin. Initially, the theoretical prediction is that the temperature of the universe at the time of Big Bang was as high as 10 to the power 32 Kelvin. So high. Anyway, so after that time period, the temperature reached to 3000 Kelvin, recombination started, and therefore the photon particles could emerge from that area, and now we can see whatever we can see right now is called CMB, cosmic microwave background radiation. And by analyzing the data obtained from CMB, we can know many things about the origin of the universe, structure of the universe, development or evolution of the universe. Though still research is going on in this field. This is the field of cosmology. This is known to you. Okay, because everything is not clear up to now, up to the present moment. Different satellites were sent to collect data, such as COBE, means Cosmic Background Explorer, COBE, COBE, Cosmic Background Explorer in 1989. Okay, then again in 2001, WMAP, that is Wilkinson Microwave Anisotropy Probe. This is also a satellite that was sent in 2001, and in 2009 Planck satellite was sent to collect data of CMB. At present, the temperature of the CMB is 2.725 Kelvin. Yes, it is almost minus 270 point something. Okay, you can easily calculate. Because in Kelvin the temperature is 2.725 Kelvin. So in degrees Celsius it would be almost like minus 270 point something. This is the present temperature. Because already means universe was created. Our present data is saying us that the universe was created 13.8 billion years ago. So that much time has already elapsed, and due to that time, the temperature of the CMB has reached to this value. Okay. So at present, what is the problem? Problem is that the radiation which we are receiving from CMB is mixing up with the foreground radiation, such as radiation from our own Milky Way galaxy. Then beside this, Andromeda galaxy is there. So since the radiation from CMB and the radiation from the foreground are mixing with each other, so the problem is we need to distinguish and separate those signals. Then only we can analyze. So this is quite challenging. Yes, to some extent, scientists have become able to do this task. And this way, they are progressing. Our science is progressing. We are going more close to know everything about the origin of the universe. Okay, so this one, yes, there is one more theory, inflation theory. That is a rapid expansion of the universe after the Big Bang. So that theory has also been proved by analyzing CMB data, CMB radiation data. Inflation theory, that is known as inflation theory. Anyway, in a single video, I can't explain everything. Otherwise, if I try to explain everything in a single video, then the length of the video would become so large. Okay, I should avoid that thing. Anyway, so this was all about the main topic of discussion was what? The evidence of the Big Bang. Okay, and the main evidence is the presence of CMB radiation, cosmic microwave background radiation. Okay, and scientists or researchers are still trying to get more accurate data. If you get more accurate data, then you will be able to know each and everything about the origin of the universe. Anyway, so this was all about the topic evidence of the Big Bang. Okay, so this is the end of this video. Thank you for watching this video.